Bismillahirrahmanirrahim. Today we are going to start another part of mathematics session. We are going to start with introduction to the analytical engineering. I will be with you in this session. This is the first lecture, and I will summarize what will be exactly this part of mathematics. It will be having a polar and Cartesian coordinates, and we will talk about parabola, ellipse, hyperbola, and circle, and we'll end with that general application. We'll try to have a simple way to talk about this chapter, and I'll try to have maybe 2 or 3 lectures in this week and next week to have as much as possible from the material. Our material will be having through what are we doing right now, and maybe I will upload some PDF to explain exactly the examples, and will help you in understanding the analytical engineering. Analytical engineering, in fact, is very easy subject because it talk about a simple engineering element and talk about shapes. You all studied that before as a straight line, levels, curves, and square surface according to the algebra methods. This it was a branch of engineering that we have found a long time ago, maybe during the history. Hassan ibn Haytham was one of that scientists who talk about that analytical geometry. So let's start with analytical geometry, talk about the Cartesian and polar coordinates. These things you maybe heard before and easy to talk about because Cartesian, that mean you have to axis x and y, and the polar talking about r and theta. So let's see what will be exactly. Suppose I'm having 2 Cartesian coordinates x and y axis, and we need to get a point, and this point will be as an intersection. So let me explain that and verify it. If I have x axis and y axis, and this is the ordinate point, and we start moving parallel to the x axis, distance x far from this ordinary with space of y, and similar to that, and I get y. Then we have here intersect point. This point will be P, and the position of that P, it will be how much move on that x axis and how much will move from that on y axis. That's what means coordinates, and this called Cartesian. Suppose I'm having that one, and I'll try to have we have point at level those 2 axes, and we need to change that from Cartesian to polar. First, we have to identify the position of P. يعني لازم نجيب مكان نقطة B. The position of B is a magnitude, and the sign of x and y it will be depend on the quarter you have. So لو أنا نازل لتحت هيبقى بالسالب، لو أنا جاي في اتجاه الآخر من الناحية الثانية هيبقى الإكس هي اللي بالسالب والواي هي اللي بالموجب. طيب let's talk about the polar coordinates. What is the polar coordinate? Polar coordinates that mean we have P determined a coordinate to the fixed point P at the level called pole. So we have pole like that, and we have x-axis and y-axis also. The position of P will be determined from R and theta, and this theta should be measured from that x in direction against to the clockwise. So we see it as a counterclockwise and should be positive. So if I took that direction, I mean the opposite direction, it will be negative. Also, when we get P, so it will be a function of, like we talked about before, that x and y as a position in Cartesian coordinates. So it will be R and theta in polar coordinate. What is the relation between Cartesian and polar coordinates? Easy. That we have x-axis, y-axis, and if we move x distance and y distance, we will get b and of x and y. So means that we have whether r and theta be as r and theta or b as an x and y. If we look to this triangle is a right triangle, and I have here x and y, and this will be the chord between both of them. So r and theta is a function to give me the polar case. X and y give me the Cartesian case. So with a simple way to look at it, so you will find that if we took x over r, we will get cosine theta, and if we take y over r, we will get sine theta. So the easy way to get and y equal r sine theta. How did this come from? لو بصينا الاكس هنا والعلاقة بينها وما بين r هو ان ثيتا هي اللي بتربط ما بين الاكس والار، حيث كوزين ثيتا عبارة عن اكس اوفر ار، ساين ثيتا هي واي اوفر ار. سو لو احنا عندنا ار وثيتا نقدر نجيب قيمة اكس. Then you can get the value of x equal r cosine theta, y equal r sin theta. يبقى احنا لو عندنا قيمة r وعندنا قيمة theta نقدر نحولها إلى x أو نحولها إلى y بارتباط إما كوزين أو سين. الكوزين بتبقى على الأفقي والسين بتبقى على الرأسي، وبالتالي هيبقى عندنا كوزين ثيتا هتديني x وسين ثيتا هتديني y في حال اشتراك الار معا. If you look in another face of coin, we find that Cartesian topology means that you have x and y. To get r, you will get square root of square x plus y, or if you want to get theta, that means tan minus 1 y over x. So this is the relation you have. Then, if I give you an example or a problem that we need to change the polarity instead of Cartesian, you go to this form. if I wanted to change the polarity to x and y, so you will get this form. This example telling me that we need to get the Cartesian coordinate for point A, which have r equal to and theta minus 60. This example is easy to get it because that's our x, and we're moving down there with next to the 60 negative, or with negative sign, and the value of r is equal to units. Then that's our values. This theta and this also apply in the equation x equal r cosine theta, so it will be 1, and y it will be r sine theta, not cosine theta, r sine theta, like this. It will be negative 3. So this one cosine theta and this one sine theta, so we'll get that one. So A in Cartesian will be 1 and negative square root of 3. That's easy way. Let's get another example. Here we need to get a polar coordinates from point P, which x equal minus 2 and y equal to square root of 3. So I'm going to have this one like that. So this is a value of y and this is a value of x. So what will be the coordinate of that one? What will be the polarity of this here? Easy. So we will have r, which we needed, and theta will be all that, and it will be counterclockwise, so it will be positive. Let's have the equation. We have x and y, right? So we put it under square root, and this positive sign, x square y square, summation of them under square root will be r equal 4. And what will be the theta? Theta tan theta, it will be y over x. It will be negative 3, and theta will be 120 degree, and it will be the value for r, and theta will be 120. Easy way, we have it like that. We will see if we have a distance between 2 points in terms of coordinate, Cartesian coordinate. The distance between A and B of Cartesian coordinates, we are applying Pythagoras theorem. Let's see if we have x and y, and I'm having x1 and x2 and y1 and y2, and we have a distance between both two intersection points. Here we'll get ax and y, x1, y1. For B will be x2, y2. So the vertical distance will be the value between y1 and y2, and the horizontal one will be the distance x2 minus x1, and this will be the chord between them. So this value will be square value equal x square and y square. So easy way to get that straight line. How much it will be? It will be that value. The distance between 2 points for polar 1. So that x, and we have r1 with theta 1, and we have r2 with theta 2, and we need to get this distance between A and B. So it will be with Lorentz theorem, which said that this one square will be R1 square plus R2 square negative 2 R1 R2 cosine theta 1 minus theta 2. Of course, the distance between 2 points by known ratio. Let's see if I'm having C point and this C divided the distance between A and B, where A x1 y1 and B x2 y2 is required to find the inside or outside in ratio 1 and 2. So we needed to see if it's inside, how it will be, and if outside, what it will be for the similarity of 2-point triangle. Let's see what talk about that. If I'm having x and y and I'm having 2 point A and B, which A on x1 y1 and it B x2 y2, that's our straight line, and we need to have that distance, this point which divide that one. For that triangle ABM, and we divided that triangle to another small one ACL. So we have this one and that one. This is dividing points and giving me ratio R1 and R2. Means maybe this ratio 2 to 1, 1, 1, 3 to 1, whatever. And of course, this C between A and B, so we talk about inside point partition. So this C will divide AB from inside because between A and B. Of course, if I'm having a line like that and A x1 y1 and B x2 y2, and that line give me x and this one will give me y. So we have triangle right now ABM, and we need to get the division point or the point with divide this line A and B, which C will get two triangles and R1 and R2. So what will be X and what will be Y? That's our problem right now. We need how can we get X from X1 and X2 and R1 and R2, and how can we get Y from Y1 and Y2 through R1 and R2. The first one saying, okay, if we take this one for that triangle R1 in using the whole triangle, this one, so that one will be all together R1 plus R2. So with the division right now, R1 over R1 plus R2 will get this one. For X, so to get this part which in that triangle, so we'll see that X1 minus X minus X1 to get this one, over for that all one will be X2 minus X1, and this will give me X with that 4. So if I'm having X2 and X1, R1 and R2, so I can get X from this formula. Similar for that, we can get Y. So R1 over R1 plus R2 mean you will talk about that Y minus Y1 over y2 minus y1. We will get that y like this. لو قلناها بسرعة كده هو بالعربي عشان الناس اللي هي مش قادرة تاخد بالها من العملية ديت، أنا عندي من جد تراينجل أهو الصغير دوت، وبالتالي R1 بتمثل هذا الوتر في المثلث القائم ده. بالنسبة للمثلث الثاني الكبير فهيبقى عندي R1 بلس R2 عشان يديني الوتر الكلي. لو أخدنا الوتر الصغير على الوتر الكبير ده مين؟ إن أنا عندي ده R over R plus R2 R1 plus R2. طيب لما نبص لل R1 ده قصاده القاعدة دي إيه؟ X ناقص X1. يبقى أنا هحطها X ناقص X1 شبيهة للR دي. ولما أحب أجيب القاعدة الكبيرة اللي هي AM هلاقيها X2 minus X1 اللي هي دي. وبالتالي X بتاعتي هتطلع لي دالة في X1 و X2 و R1 و R2 ودي الشكل بتاعها أو الدالة بتاعتها أو الفورمولا بتاعتها أو الصورة بتاعتها. نفس الحكاية بالنسبة للواي بهذا الشكل. Now we have inside ودي بتبقى positive signal. لو عندي A و B this will be our line and C inside, so we will have ratio R1 with the other part to be R2. So outside means that A and B and this C outside, so it will be outside, not in between. So R1 will be the small one, this one, like that one exactly, and the R2 it will be this one, the longest one, because all the time R1 represent the distance between AC, and R2 will represent BC. Okay. Special case we will when the line connecting AB is divided eventually R2 R1 R2 there's a ratio, so the division for the coordinates are ان انا اخد x1 plus x2 على 2 y1 plus y2 على 2. ليه؟ لان r1 equal r2 يعني بنقسمها بالتساوي، فكأني بجيب المتوسط بالظبط. لو انا عندي الاي بي ديت وعندي دول واحد بواحد يبقى معنى كده اخد متوسط x1 و x2 واخد متوسط y1 و y2 لان الريشيو هنا ثابت. دي سبيشال كيس. طيب لكن لو جينا نشوف عندنا مثلث AB عايزين خط AD سوري في المثلث ABC. طيب اهو ادي اللاين بتاعنا AD ده، عندنا نقطة متوسطة بس ب2 إلى 1 يبقى أنا عندي G هنا دي المسافة دي 2 المسافة دي 1 يعني R دي ب2 والR دي 1. الخط ده موجود فين؟ موجود في مثلث ABC. A بتمثل x1 y1، B بتمثل x2 y2، C بتمثل x3 y3. طيب تعالى نبص بالشكل اهو. A represent x1 y1، B x2 y2، C x3 y3. The ratio is there 2 and this one, and this is the value the point of division. Okay. For our dividing, if we look here, this one comes and divides that one exactly to half. To half means this part equal to that part. So if I wanted to get D, that means x2 and x3, we will get the mean of it, the average of it. So I will take x2 plus x3 divided by 2 and y2 plus y3 divided by 2. So right now that d. For our x, for the 3 x1, x2, x3, so it will be divided by 3. And y, for the 3 of them, will be y1, y2, y3 over 3. So that means if I'm having مثلث متساوي الأضلاع means إن أنا عندي x المتوسطة هتساوي متوسط 3 قيم من x1 وx2 وx3 و y تبقى y1 y2 y3. طبعا عملية سهلة جدا وبسيطة مفيهاش أي مشاكل. طيب لو قلنا 2 ل1 وحسبنا إن إحنا عندنا أكتر من خط بيتقطع، يعني عندنا بقى مش دي بس، عندنا E وعندنا F، كل واحدة من دول هطبق فيها نفس القاعدة، هاخد x1 وx2 وx3 y1 y2 y3 الثلاثة هيتقاطعوا في النقطة G، وبالتالي تنطبق هذه القاعدة على كلهم. شكرا على استماعكم ليا. We will meet in another lecture to complete our shape, the conical one. You have many exercises. I will give it to you through PDF, and I will try to upload this one to the class room, which I will put this video with that exercise for the Google Classroom. Thank you very much. We will meet soon in another lecture.